Hey everybody. In class we've been working a lot on graphing equations and functions. Tonight we're going to talk about a different way that you might see functions written. The math isn't really any different, it just might look a little different. So to start, we have a linear equation y equals negative 4x minus 2, right? We've seen a lot of things that look like this. We know our y-intercept is negative 2. We know our slope is negative 4. Sometimes, however, this equation might be written a little differently. You might see it written like this. Now, this doesn't mean anything different from the way we had it written previously. Notice the right side of the equation is exactly the same. We still have a y-intercept of negative 2 and a slope of negative 4. The only thing that's really different is how we write the output. Now, it doesn't matter which way it's written. In both of these functions, the thing on the left side represents the output. In our first equation, in yellow, the y represents the output. In our orange function, this symbol right here, f and then x in the parentheses, represents the output. That symbol is just another way of representing y, or the output. It means the value of function f at x, but we usually just say f of x. You can also use other letters instead of f, like g or h when you have multiple functions. So when we see this first one up here in orange, we say f of x equals negative 4x minus 2. Let's take a look at a couple of examples. Here we have two functions, and we want to evaluate each function when x equals negative 5, 0, and 4. So let's just take this one step at a time. When we're trying to find the value of function f when x is negative 5, we write it like this. We write f, and then in parentheses we write what input we're using. And we say f of negative 5. So this tells us the value of f when x is negative 5. And then on the right side where we have the actual function, we insert negative 5 for x. We substitute. And then we put minus 2. Negative 4 times negative 5 minus 2. And then we write f of negative 5 equals negative 4 times negative 5 is 20. 20 minus 2 is 18. F of negative 5 equals 18. And now we just have to do that for our other two values. F of 0 equals negative 4 times 0 minus 2. So f of 0 equals negative 2. Negative 4 times 0 is 0, minus 2 is negative 2. So there's f of 0. And now we find f of 4. Negative 4 times 4 minus 2, that's going to be negative 16 minus 2 is negative 18. So f of 4 equals negative 18. So this is really just a way of showing what the function is equal to for each input, right? F of negative 5 equals 18, f of 0 equals negative 2, f of 4 is negative 18. We're going to do the same thing for function h here. I'm going to put in negative 5 for x. So I got h of negative 5 equals 3 over 5 times negative 5 plus 6. So h of negative 5 equals, let's see here, 3 over 5 times negative 5 is negative 3. Negative 3 plus 6 is 3. And there's h of negative 5. Then we have h of 0. 3/5 times 0 plus 6. That's obviously going to be 6. And then we have h of 4. 3/5 times 4 plus 6. So h of 4 equals 3/5 times 4, that's 12/5. And 6, if I multiply by 5 over 5, that gives me 30/5. So that's going to give me h of 4 equals 42/5. Now, in some situations, we're going to want to find the input value. For the function below, find the value of x so that f of x equals 6. Now here they're telling us f of x, the output, is equal to 6. So we can just substitute 6 into our equation for the output. 6 equals 2x minus 10. And now all we have to do is solve for x. Add 10 to both sides. 16 equals 2x. And then we divide by 2. And we get x equals 8. So when the output is 6, the input must be 8. All right, that's all the notes we have for tonight. Go ahead, finish them up, and submit them through Canvas. I'll see you guys tomorrow. Have a good night.